Good evening, all of you. Somebody please send the message. Good evening. Shall we start? Yesterday we have discussed about some of the problems on the theorems on integral calculus given in the previous examination. So today also we discuss some more things. Some more problems we were given in the previous examination. So find the value of integral 1 to 2 y dx when x is related with y, x is related with y as shown in the diagram. X is related with y as shown in the diagram. Please note down this. Please confirm, are you getting my voice in video clear? Say yes or no. Here y is related with x by the shown diagram. Then you have to find integral 1 to 2 y dx. Integral 1 to 2 y dx. Please tell me the value. Here we have to find the equation of this right line. So instead of finding the equation of this right line, just the relation between y and x can be easily obtained by this value. Here we can say that x equals to minus 1, y equal to 0 from this diagram. And at x equals to 0, y equals to 1. So from these two, you can write a relation. You can write a relation between y and x. Y equal to x plus 1. Here, x is minus 1, y is x plus 1. Minus 1 plus 1. Nothing but 0. When x is 0, y is x plus 1. 0 plus 1. Think of this. So this relation you can draw this diagram. This relation you can draw from this diagram. And then directly the answer will be integral 1 to 2. The integral will be y is nothing but x plus 1 dx. So this is equal to integral of x is x square by 2 plus is x. Limits from 1 to 2. If you write the upper limit value, 2 square by 2. Nothing but 2 plus 2 minus. This is the upper limit value. Lower limit value for x equals to 1. 1 by 2 plus 1. So the answer is 4 minus 1, 3, 3 minus 1 by 2. Having 5/2, or if it is asked in the numerically answered question, the answer will be 2.5. Is it clear? Please send a message. Please confirm. Please confirm. Is it clear? Some of you please send a message. Now write down next definition regarding the gamma function. Please note down gamma function. Gamma of n equals to negative 0 to infinity e power minus 6 x1 minus 1 dx. Negative 0 to infinity e power minus 6 x power minus 1 dx. Do remember this definition if you are getting any improper integrals. If the limits are from infinity to infinity or minus infinity to infinity, 0 to infinity, or minus infinity or minus infinity to 0, those are known as improper integrals. Proper integrals. Okay. Now if you consider such improper integrals, we are going to use this gamma definition. And here we have the right complete concepts. Gamma of 1 equals to 1. Gamma of half equals to root 5. And gamma of n plus 1 equals to L factorial if n is positive integer and this is equals to n into gamma of n if n is rational such that n plus 1 is positive. N plus 1 is positive. So this is gamma function. So based on this gamma function, we can evaluate the improper integrals. Improper integrals means when the limits are from 0 to infinity, call them as improper integrals or minus infinity infinity. Okay. So I think this is finished. Now we do a problem related to this which was given in the previous examinations, particularly for you people. So please note down that problem which was given in the previous examination. It's proper integral. Find the value of integral 0 to infinity e power minus x squared by 8 dx. I'm doing one more 1 by 5. Please note down this. So we are having the limits from 0 to infinity, then you can utilize this one. When it is involved with the e power minus x. E power minus x square by 8 dx. So here I am going to write this entire x square by 8 as t. When x is tending from 0 to infinity, t also tends from 0 to infinity. So x square by 8 means you differentiate this. On differentiation, 2x dx by 8 is equal to dt. Use these substitutions or that. Use these substitutions or that. So what you can write? 1 by root 2 pi. When x limits from 0 to infinity, when x is 0, t is also 0. When x is infinity, t is also infinity. From 0 to infinity. E power, this is minus t. And dx is, this is 2 by 1 by 4. 4 dt by x. 4 dt by x. If x square by 8 is t, then x will be root 8 to t. Square root of 8 to t. X will be square root of 8 to t. I repeat this once again. Here I am taking substitution x square by t because we have e power minus 6 0 or minus x. So the entire e power it's something that something I am taking as t. Then x will be square root 8 to t. Square root 8 to t. So therefore, Now x dx is equal to of this. Dx is nothing but 4 dt by x. X is root 8t. So this I have substituted here. So this is equal to 1 by root 2 into root 8 will be root 16 nothing but 4. Root 5. Integral 0 to infinity. E power minus t. This 4 gets cancelled. 4 is here. So no need of writing that. Cancelling that 4. Now root 2 means e power minus half dt. This you can write it as 1 by root 5 and 0 to infinity e power minus t. T power minus half can be written as t power minus half can be written as minus half can be written as 1 by 2 minus 1 dt. Now if you compare this with the gamma definition, gamma of n equals to integral 0 to infinity e power minus x exponent minus 1 dx. You can say the answer now. Please tell me the answer, please. Yes. Yeah. Can somebody say the answer? Can somebody say the answer? Comparing this with that gamma function definition. Let it make fast. Tell me what is the answer? This is e power minus x power n minus 1 dx. So this is nothing but 1 by root 5. And integral 0 to infinity e power minus x exponent minus 1. X is replaced by 3. So you will be having on 8. So 1 by root 5 into gamma half. Gamma half is nothing but root 5 by root 5. This is equal to 1. So this was asked for computer science only previously in examination. Try to do, remember and follow that gamma definition for evaluating such kind of things. Have you finished? Say yes or no. Please send a message quick, make it fast. Have you done it? Try the next one. Okay, I'm 0 to 5 by 2. Sine power n x dx is equal to 0 to 5 by 2. Cos power n x dx. Both are equal. If you apply integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Based on this formula, you can say that a is 5 by 2. So sine of 5 by 2 minus x is cos x. Therefore, you can say sine power nx is nothing but cos power nx. So this is equal. These two are equal. I'm going to give you some simple things. Integral 0 to 5 by 2 sin x dx is equal to how much? Integral of sin x is derivative of sin is plus cos. Integral of sin will be minus cos. Minus cos x. Limits from 0 to 5 by 2. If you write the upper limit, cos 5 by 2 will be minus 0 minus of minus plus. Cos 0 is 1. The value is 1. Okay. The same thing you will be getting for cos x also. So if n is odd, we will start with the 1. Write the value as 1. If n is odd, positive integer. N is odd, positive integer. If n is odd, positive integer, and n equals to 1, the value is 1. Say, for example, n equals to 3. What it will be? Integral is equal to 5 by sine cube x dx. Sine cube x dx. Here what I am doing is sine 3x equals to 3 sine x minus 4 sine cube x. I'm using this now here. So this if you write it towards the left, this will be integral 3 sin x minus sin 3x by 4. 1 by 4, 3 sin x minus sin 3x dx. Limits from 0 to 5 by 2. Now, if you do the integration for sin x, integral of sin x is minus cos x. So this is 3 by 4 minus cos x, and that's minus 1 by 4 minus cos 3x by 3. You write the limits from 0 to 5 by 2. On writing upper limit, both will be zeros. On writing the lower limit, you will get minus, that minus minus will become plus. Cos 0 will be 3 by 4. And on writing lower, cos 0 will be 3 1 by 3 into 4. So this minus you will be getting minus 1 by 12. If you take LCM, this will be 10. And 4 3 is 9 minus 1. So this is 8 by 12, 3 by 2 by 3. Why I have written this? Just to show this is the previous one will be 2 by 3. And the before one will be add 2. And add 2 to this denominator, 4 by 5. And again, before to this, 6 by 7. And so on. And so on. The numerator is 1 less than the denominator. We had given sin power n or cos power n. So what you can write is n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4. So this is the thing. Integral 0 to 5 by 2 sin power n x cos power n x dx can be written as n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4 into so on. So on. 6 by 7 into 4 by 5 into 2 by 3 into 1. When n is odd positive integer. Odd positive integer. Odd positive integer. Similarly, you can write the same n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4 into so on. So there's no change in those terms. The last one will be 5 by 2, and before that 1 by 2, and before that 3 by 4, and before that 5 by 6, and so on. If n is even, positive, even integer, positive, even Z. Very simple. So if it is 0, integral 0 to pi by 2 sine power 0 x dx is nothing but 0 to pi by 2 1 dx. Nothing but x limit from 0 to pi by 2. On writing the upper limit is pi by 2. Starting with pi by 2. Try to remember this formula from right to left. You can easily remember these values in this manner. So again, if you want to write 0 to pi by 2, sine square x dx. The sine square x can be written as 0 to pi by 2 1 minus cos 2x by 2 dx. If you write that 1 by 2 out, 1 by 2 into L of 1 is x minus L of cos 2x is sine 2x by 2. Limits from 0 to pi by 2. This is equal. On writing the upper limit pi by 2, this will be pi by 2. And lower limit is sine pi will be 0. And writing lower limit, this is 0, this is 0. So the answer is 1 by 2 into pi by 2. So if you want to write sine square, if you want to write sine power 0, if you want to write sine power 0, you have write pi by 2. Sine square means 1 by 2 pi by 2. Sine power 4 means 3 by 4 into 1 by 2 into pi by 2. Sine power 6 x dx will be 5 power 6, 3 by 4, 1 by 2 pi by 2. So you have to multiply all these 4. Sine power 6x. In the same manner, if you want to write sine power 7x, 6 by 7 into 4 by 5 into 2 by 3 into 1. If you want to write sine power 5x, 4 by 5 into 2 by 3 into 1. If you want to write sine cube x, 0 to pi by 2 sine cube x or cos cube x, 2 by 3 into 1. You want to write 0 to pi by 2 sine x or cos x, the value will be only 1. This is the way how you have to remember. Have you finished? Please note down. Actually, this formula has written this. You have finished? Please tell me now quickly. Get fast. Send the message. Please send the message if you have finished it. Or if you are having the doubt, you can ask me. Yes. Really? What? 6 grammar. चलो चलो ऐसा होगा। Have you finished or not? Now, related to this, let me give you one problem. Find integral 0 to pi by 2 cos power 11x. By observing this, you can say the solution by considering this. Integral 0 to pi by 2 cos power 11x dx. Tell me the value quickly. Can you do it or shall I explain? Very simple. After discussing this entire thing, the cos power integral 0 to pi by 2 cos power 11x dx. 11 is odd positive in Z. So for 1, you have to start with 1. For 3, 2 by 3. For 5, 4 by 5. For 7, 6 by 7. For 9, 8 by 9. For 11, 10 by 11. 10 by 11 into 8 by 9 into 6 by 7 into 4 by 5 into 2 by 3 into 1. This is the answer. You multiply all the numerators and denominators. That is the answer. That's enough. So here you can simplify like this. This is 3 rows and 3 trees. That's enough. Yeah, 5 rows. You may multiply now the numerator and discuss this denominator. Okay. 33 trees. 99 into 7. 99 into 7. 700 minus 700 minus 7. I think 693. The numerator is 2 into 2 into 2. 8 into 8. 64. 64 into 4. 64 into 4. 256. This is the answer. Even for such kind of things, also directly you can write the answer. Say yes or no. Is it clear? Is it clear? Is it clear? Please somebody respond. Somebody respond with the message. Is it clear? No response. So just write another one more formula. Integral 0 to pi by 2. Sin power x cos power mx dx. Sin power mx into cos power mx dx is equal to gamma m plus 1 by 2 gamma m plus 1 by 2 whole divided by 2 into gamma m plus 4 by 2. Into gamma of m plus 2 by 2. Just do remember this, and you know the value of the gamma, gamma half, gamma 1, and gamma of m plus 1, how to find those values whenever they are required. Okay. So this is about the theorems on integral calculus and some of the important problems that we have discussed or given in the previous examination. Okay. Is it okay or not? Okay. Hello. Somebody please respond. Is it okay or not? You're not responding. If you say yes, then we will continue for the next one. Next topic. That is maximum and minimum. Last topic in calculus, not very calculus. Discuss one problem. When is it today? Very simple one. Integral 0 to pi Integral 0 to 5. Cos power mx sin power mx dx is equal to 0 is equal to 0 if write the options. M is even, option B. M is odd, option C. M is even, option D. M is odd. Tell me this. With this, we will conclude this topic and move on to the next one, maximum and minimum. Tell me quick, take it fast. See here, we are having integral 0 to 5. 0 to 5 means we need to convert into 0 to 5 by if you want to utilize this. Actually, it has no use in doing this one. Okay, if you want to do this one, that one is not going to be applicable here. So what you can do is, if f of x is cos power mx sin power mx. Okay. Then f of pi minus x is equal to cos of pi minus x whole power n into sin of pi minus x whole power n. So this is equal to cos of pi minus x is minus 1 power n cos power mx. Cos of pi minus x is 0, pi by 2, pi, 3 pi by 2, 2 pi. Sin is positive. Sin is positive in first and second quadrant. Cos is positive in first and fourth quadrant. So pi minus means this one. If it is x, pi minus x is this. So cos is negative in the second quadrant and sin is positive in the first quadrant. So the sin of pi minus x will be, so from this cos of pi minus x equals to minus cos x. And sin of pi minus x equals to sin x. So sin power n pi minus x. So sin power nx. Sin power nx. So f of pi minus x is nothing but, what is it? Minus 1 power n cos power nx sin power nx. So here we have given this is 0. This is 0. So when this will be 0, integral 0 to 2a f of x dx equal to 0 if f of 2a minus x equals to minus f of x. That was a formula which we have written yesterday. Integral 0 to 2a f of x dx equals to 0 if f of 2a minus x equals to minus f of x. So what we are getting is we have f of 2a minus x. That should be minus f of x. So in order to say that will be 0, that will be 0, f of pi minus x must be equal to minus f of x. So it will be minus f of x if m is odd. If m is odd, positive integer, then only it will be minus f of x. So based on this formula, this is 0. So it will become 0 when f of pi minus x equals minus f of x. That will happen only when m is odd. If m is even, f of pi minus x will be f of x. Then it won't be 0. So in order to say that it will be 0, so definitely f of pi minus x minus f of x. So that minus f of x will come when m is odd. So the answer is m is odd. M is odd. Is it clear? Is it clear? Say, is it clear or not? Say, is it clear or not? Somebody please respond. Somebody please respond. Next, we are having one more formula, integration as the limit of the sum. Summarizing this, integration as the limit of the sum. Integration as the limit of the sum. Limit tends to infinity 1 by n summation r equals to 1 to n f of r by n. F of r by n. is equal to f of x dx. Of x dx. F of x dx. Same thing you may write in tenders to infinity. 1 by n summation r equal to 0 to n minus 1. F of n. That is also equals to, if it is from 1 to n, there are 0 to n minus 1. That also equals 0 to 1. F of x dx. F of x dx. Quickly we do one or two problems on this, and then we'll move on to the next topic, maximum and minimum. Okay. So let you write a problem. Limit n tends to infinity. N by n squared. Limit n tends to infinity. N by n squared plus n by n squared plus 1 squared plus n by n squared plus 2 squared plus log n by n squared plus n minus 1 squared. Find the value of this one. Find the value of this. So here it is just like the topic above 0 to n minus 1. So n by n squared plus 0 squared, n by n squared plus 1 squared, n by n squared plus 2 squared, so on n by n squared plus n minus 1 whole square. This you may write it as limit n tends to infinity. Among all the numerators, you are having n, and again from all the denominators. From all the denominators, what you can write? From all the denominators, you can write n by n squared can be taken common 1 plus 0 by n whole square plus second term will be n by taking n squared common 1 plus 1 by n whole square plus so on. The last one will be n by n squared into 1 plus n minus 1 by n whole square. So this I'll write it clearly here in the bottom. plus n by n square 1 plus n minus 1 by n whole square closed. Now among all of these, 1 n gets cancelled. 1 n gets cancelled. So that 1 by n can be taken common. This you can write as limit n tends to infinity 1 by n into 1 by n into summation r equals to n 1 by 1 plus 0 by n r equal to 0 to n minus 1. One by 1 plus r by n squared. R by n squared. If you put r equal to 0, you're getting the first term. R equal to 1, you're getting the second. R equal to 2, the third one. R equal to n minus 1, that last one. So this is the thing that we had. So what you can do now, this you can write as integral 0 to 1. What is the function? That function is 1 by 1 plus r by n can be written as x. 1 by 1 plus y dx. So this r by n is going to be written as dx. If it is of such form. So what is integral of 1 by 1 plus x squared? This is nothing but tan inverse x. Limits from 0 to 1. So the value is tan inverse 1 minus tan inverse 0. So tan inverse 1 is pi by 4. Now tan pi by 4 is 1. Tan inverse 1 is pi by 4. Next tan 0 is 0. Tan inverse 0 is 0. Minus 0. The answer is pi by 4. Please note down this. Make it quick fast. Please somebody write a message. It's okay or not? If you are having the doubt, you can raise the doubt. If you want me to explain it again, I'll repeat it. Is it okay or not? Please respond. Send the message saying just okay. Try now next one. Limit n tends to infinity. Limit n tends to infinity. N factorial by n power n. All power 1 by n. Limit n tends to infinity. N factorial by n power n. Whole power by n. I'm just removing this. So if you're getting this some function whole power the same function of n on x, let you consider this as y. Now I'm going to apply log y. You have to bring this 1 by n into the write it as a factor. So you have to apply logarithm. Logarithm of limit n tends to infinity n factorial by n power n whole power 1 by n. So that power will come into before to this logarithm as a product of it. What we are getting now, this is equal to 1 by n, 1 by n, or you may write logarithm inside to this, limit n tends to infinity, logarithm of n factorial by n power n, 1 power 1 by n. Now this power comes in before to this, log m power n equals to n into log m. Limit n tends to infinity, 1 by n into logarithm of n factorial by n power n. N power n. So here you are getting now n factorial can be written as this is equals to limit n tends to infinity, 1 by n logarithm of n factorial can be written as 1 into 2 into 3 into so on n. N power n can be written n into n into so on n. N into n into so on n. So n times we are multiplying this denominator n. So log here we have applied log m power n equals to n into log m. This is one formula. And another one is log ab equals to log a plus log b. Whatever the base that it may be. Whatever the base that it may be. So you can consider the base as E. Base as E. Base as E. Base as E. Okay. So E. E means natural base. So I'm going to write this as limit n tends to infinity 1 by n logarithm of 1 by n plus logarithm of 2 by n plus 1 logarithm of n by n. Logarithm of 1 by n plus logarithm of 2 by n plus logarithm of n by n. So this you can write it as limit n tends to infinity 1 by n summation r equals to 1 to n logarithm of r by n. Limit n tends to infinity 1 by n summation r equals to 1 to n logarithm of r by n. If you put r equals to 1, log 1 by n. R equal to 2, log 2 by n. R equal to n, log n by n. All these are this into 1 by n. Limit n tends to infinity. This you can write it as integral 0 to 1 log x dx. Log x dx. Now again I am going to apply integral uv formula. Integral uv equals to u into integral v minus integral du into integral v. Du into integral v. So here logarithm by highlight formula, logarithm to be considered as v and 1 to be considered as u. There is nothing, you may write 1 as u. So as per this above formula, u is, what is u? U is 1. Highlight formula. Logarithm. Sorry. You cannot write highlight. What is highlight? I for inverse. L for logarithmic. A for algebraic. T for trigonometric. E for exponential. So as per this, logarithm comes before to algebraic. So log x is u now. 1 is b. So log x is u. Log x into integral of 1 dx minus integral derivative of log x by x into integral of 1 dx whole dx. Total limits from 0 to 1. I repeat, highlight formula. Logarithm is before to algebraic. Only single log x is given. Multiply with 1. That is also same. 1 is algebraic, logarithm is logarithm. So consider logarithm comes before to algebraic. So consider logarithm as u and 1 as v. U into integral v. U is log x. Log x into integral v, integral 1. So next integral derivative of u. Derivative of log is 1 by x, integral 1x, overall dx. So integral 1 at dx is x. So this is equal to x into log x, limit from 0 to 1, minus here integral 1 dx is x gets cancelled. Integral dx is x only. Again from 0 to 1. If you write 1 here, 1 into log 1. Log 1 is 0. I'm writing the lower limit 0 into this one, anything is 0. Minus, I'm writing the upper limit 1, lower limit 0. So this is minus 1. So the value y is, log y is minus 1. The value log y is minus 1. This is nothing but log y. This we have calculated. So log y is minus 1. Then what will be y? Log y is minus 1. Log y x is minus 1 plus y equals to e log x is equal to 1. That is the answer. The required answer is 1 by e. The required answer is 1 by e. Everybody have got finished? Tell me quick. If you send the message, then we are going to write the definition of maxima and minima, and we'll be discussing some important problems related to them. Tell me quick, make it fast. Send the message. Some of you please send the message. Some of you please send the message. Yes, please. No response. Have you finished this? Any doubt regarding this? Any doubt? Yes, please write the next one. Maxima and minima. Say yes or no. No one is responding. What's happening? No one is responding. Write down next. Maxima and minima. Maxima and minima. Write down a function f of x, a function f of x is said to attain maxima, at x equals to a, at x equals to a, at x equals to a. If if there exists a small h, if there exists a small h frequency flow such that f of a minus h comma f of a plus h less than f of a. And I am maxima. This is f of a minus h, f of a. This is f of a plus h. This is a very small different state. This is a very small different state. Please note that diagram, then you will have some understanding about this definition. Normally, we used to find the first derivative, second derivative, and so on like that. It's not the actual definition. This is the actual definition. If there exists a small h greater than 0 such that f of a minus h and f of a plus h both are less than the function value at a. So then you can say f of x attains maxima at x equals to a. F of a is the maximum value. Write down. Here, f of a is a maximum value. For next, minima. Say the slide of this. A step of A. A minus H. A plus H. Step of A plus H. This is the of A minus H. And this is minimum. Right now, a function f of x attains minima at x equals to a if there exists a small h greater than 0, small h greater than 0, such that f of a minus h comma f of a plus h, f of a plus h greater than of a, f of a minus h comma f of a plus h is greater than f of a. And we say that the function f of x attains minimum at the point A. And f of a is known as minimum value here. Please write. And here, f of a value is known as, here, f of a value is known as, f of a value is known as minimum value. F of a value is known as minimum value. Okay. So actually, at A, there is a term for minimum. And at A also there is a term. There is a term. The point at which the function attains either minima or maxima is known as turning point. Right? Right now. The point at which the function, the point at which the function, f of x attains either minima or maxima, is known as are known as, they are known as turning points. Are known as turning points. So we are having a term here, minima, and a term there at maximum. Okay. So why I have drawn this and why I have drawn this horizontal line? It is strictly horizontal here, and there also it is strictly horizontal. Okay. At the turning point, if you write a straight line, it is parallel to x-axis. That straight line touches the curve at that point only. At that point, or at that function value f of a only. Okay. Now, this is known as tangent. If a straight line touches a curve at only one point, that is called as tangent. Now this is parallel to x-axis. The slope of any line parallel to x-axis is 0. So the slope is going to be calculated by using first derivative of any function. First derivative of any function. Now that's why either at minima or at maximum, first derivative of the function will be equal to 0. If the first derivative of the function is equal to 0, then there is a possibility of getting either maxima or minima. It's not sure, but there is a possibility. Okay, so in order to attain the maxima comma minima, we are going to write this procedure. Based on this procedure, we will discuss the problems. Right now, to calculate maxima comma minima. Maxima comma minima of any function f of x. Maxima comma minima of any function f of x. Okay, write down the first one. If f dash of x equals to 0 and f double dash of x is less than 0, x equals to a, f dash of x is 0 and f double dash of x is less than 0 and x equals to a, then f of x at times maxima at x equals to a. F of x at times maxima at x equals to a. Next, and f of a is a maximum value. A maximum value of f of x. Second point, if f dash of x equals to 0 and f double dash of x greater than 0 and x equals to a, then f of x at times minima at x equals to a. Minima at x equals to a. And f of a is a minimum value. I'm not saying the minimum, I'm saying a minimum value. Why it is a minimum value? I have so many minimas and so many maximas for any given function that we can I will explain after writing one more point here. Okay. So either for maxima or for minima, the first derivative must be 0. If the second derivative at the end is less than 0, then it is attaining maximum. The second derivative is greater than 0, then it is attaining minima. Then it is attaining minima. Even if it is the second derivative is also 0, what you will do? If f dash of x equals to 0, f dash of x equals to 0, and f double dash of x equals to 0, at x equals to a, then further investigation is required. Then further investigation is required. Further investigation is required. What is that investigation? What is that investigation? See here, you are having a point A. This is a minus A. This is a plus A. Okay. So at this, we are finding f of A minus A. And here we are finding f of A plus A. See clearly, if it is attaining already first derivative is 0, then it may attain either minimum or maximum. Now, second derivative is also becoming 0. Then we have to verify the change of sign of f dash of A. F dash. Here it is. Already f dash of A is 0. From left to right in this direction, how the change of sign of f dash of x is changing, that you have to verify. Right now we have to verify. Right. Now we have to verify the change of sign of f dash of x from left to right, at A, from left to right at A. Here, from this, the first step, if f dash of A minus h is negative, and f dash of A plus h is positive. It is changing from negative to positive. If it changes from negative to positive, from left to right, then f of x times minima. F of x times minima at x equals to A. Minima at x equals to A. How you can say that it is minima? For minima, you will be having the graph like this. If it is changing from negative, so lower value to positive value, from left to right, from left to right, this is the direction. The lower one will be f dash of a minus h. The value will be negative. To positive means it is attaining minima. It is attaining minima. Even if you want at this a minus h, this may be f dash of a minus. But this may be a minus h. This is the straight line. This is the straight line. And the angle is obtuse. So tan is negative. Tan theta is, if this is theta, tan theta will be, this is f dash of a minus h. Okay. Now, this is obtuse angle. Obtuse angle. Obtuse means in second quadrant, tan is negative. So it is changing from negative. This is obtuse. Now the angle is theta is more than 90 degrees. So therefore tan theta will be negative. And this is a plus h. This is a plus h. If you draw a tangent at this angle is theta 1. This angle is theta 1. Now tan theta 1 will be positive. This is less than 90 degrees. This is less than 90 degrees. This is the curve. At this point, draw a tangent. It is making obtuse angle. Now tan theta will be negative because it is obtuse. It is in the second quadrant. And if you draw a tangent at this point, theta 1 is acute angle less than 90 degrees. That is in first quadrant. In first quadrant, what you can say, tan theta will be positive. So it is changing from negative to positive. So since it is changing from negative to positive, this is having minima at this point. So this is the reason. Second one in this third point is if f dash on a minus h is positive, f dash on a plus h is negative, then f of x times maximum at x equals to a. So in the same manner, if the curve is like this, this is the tangent. Now this is theta 1. This is the tangent. Theta 1. And if you draw the tangent at this, it will be like this. Tangent at this point. So this is theta 2. It is obtuse angle, more than 90 degrees. So tan theta 1 is positive, tan theta 2 is negative. It is changing from positive to negative. So therefore, this f dash of a at this point will be 0. Now the curve f of x will arrive maxima. This is maxima. And this is minima. So that is the reason. If there is no change for f dash of x from left to right, that means this is positive, then it attains neither maximum nor minimum. If it is both negative and negative, then it is also not attaining either maximum nor minimum. Okay. So if it changes from positive to negative, from left to right, this direction, then the function attains maxima. If it changes from negative to positive, then the function attains minima. Right, and the third one, if f dash of x attains, if f dash of x attains, f dash of x attains, no change from left to right, from left to right, from left to right, then the function attains neither minima nor maxima, neither minima nor maxima, neither minima nor maxima at the point A, and such point is saddle point. No change for f dash of x from left to right. Such point is saddle point. Or point of inflection. Point of inflection. Saddle point or point of inflection. No maxima, no minima means point of inflection or saddle point. Okay. Is it clear? Now, either for maxima or minima or neither maximum or minima, if f dash of x is 0, there is a turn. There is a turn. That's why that point is known as turning point or stationary point. If turn is there, that is maxima or minima. Even if the turn is not there, if f dash of x is 0, only f dash of x is 0, such point is known as stationary point. Note. 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 If f dash of x equals to 0 and x equals to a, and x equals to a, then such point is known as stationary point. Stationary point. You may get or may not get. Only first derivative is 0. Second note. Turning point means definitely it will be at that point you may get minima or maximum. So all turning points are stationary points, but all stationary points need not to be turning points. Right now, already you have noted turning point. all turning points are stationary points. All turning points are stationary points, but all stationary points need not to be turning points. Turning points. All stationary points need not to be turning points. Now, if you are having another note, the curve like this. This is one minima, another minima, another minima, maxima, maxima, maxima. These are maximas, these are minima. So a function may have more number of minimas and more number of maximas. You cannot say only one minima and one maximum. Right on. A function may have is right. A function may have finite number of maximas finite number of maximas and minimas. Finite number of maximas and minimas. Not sure, may have like this. Okay, based on this concept, we will discuss one or two problems, and we are having the maximum minimum of spectral AB, and based on that logic, we will go to question. So first we will discuss and another different passion clause. That will causes that finishes the maximum. Mostly, if the time permits, tomorrow we'll finish this maximum. All the different types of problems. So from calculus, you may get the questions. Either from limits and continuity and differential. That is one aspect. The next important is maximum. And then you may go to theorems or integral calculus. But mean value theorems concept is very much required for the entire remaining. Okay. So that's the thing. And we will discuss one or two problems now today itself. Try it out. Function f of x equals to example. The function f of x equals to x cube plus 1 at x equals to 0 has. At x equals to 0 has. At x equals to 0 has. Write down the options. Option A, minima. Option B, maxima. Option C, option D, saddle point. Option D, option D, saddle point or point of inflection. Both are same. You may write saddle point or point of inflection. Point of inflection. Next, D means singular point. Singular point. Okay. So here, in order to verify, you have to find f dash of f dash of derivative of x cube is 3x squared. Derivative of 1 is 0. This is equal to 0. And x equals to 0. Next. What about f double dash of x? F double dash of x is 6x. 6x. That is also 0. And x equals to 0. As per the previous concept, if both f dash of x is 0 and f double dash of x is 0, what we have to do is we need to verify the change of sign of this is 0. Change of sign of f dash of x. Change of sign of f dash of x at the point 0. In its neighborhood. Do remember in its neighborhood. Okay, not so far. So neighborhood means you cannot take -1 and +1. At 0, you are supposed to take very near. Just for the sake of discussion, I am taking so far, but it is very near, -0.1. And this is 0.1. Should not take very far. You must take very near. So already f dash of 0 is 0. And what is f dash of -0.1? F dash of -0.1. 3 into -0.1 whole square. 3 into -0.1 whole square. Is it positive or negative? Definitely it is positive. At the 0 it is 0. And f dash of 0.1 is f dash of 0.1 is 3 into 0.1 whole square. Again, it is also positive. So f dash of x has no change of sign from left to right in the neighborhood of 0. Right on. F dash of x has no change of sign. No change of sign in the neighborhood of 0. Come, very good. That's the grammar. Lab 6:30, 6:45. How are you? So f dash of minus 0.1 is positive. F dash of 0.1 is also positive. So there is no change of sign. No change of sign for f dash of x in the neighborhood of 0. That is important. For f dash of x in the neighborhood of 0. So therefore, the function attains saddle point at 0. Saddle point. No maximum, no minimum. The double derivative is also 0. And after verifying the change of sign of f dash of x in the neighborhood of 0, you are getting positive to positive. Positive to positive means in its neighborhood, left to right. Positive to positive means no change of sign in the neighborhood of 0. So therefore, it attains neither maximum nor minimum at 0. Therefore, it is saddle point or point of inflection. Okay. You may get a doubt what is singular point. Write a note here. Write a note. Singular point means the function is not defined at that point. F of x, singular point, means f of x is not defined at that point. But the function value is f of 0 is 1. It's defined. So you cannot say that it is singular point. So it is definitely saddle point or point of inflection. This is asking for you people itself. Okay. So we will discuss some more problems on this and the maximum and minimum over closed interval, and also some of the important problems, different types of problems which were given in the previous examinations. That we will do tomorrow. So mostly we will finish different types of problems by tomorrow. It's calculus. Afterwards, we will continue the discrete maths. First important thing is graph theory. Second is propositional calculus. As we have discussed calculus, we go to propositional calculus immediately. And then after graph theory. And then after combinatorics and set theory only. We'll finish this based on the important things. Okay. If you have any doubt, you can ask. At least at the end of the class, you just please tell me, you send the message, thinking that you people are writing. Is it finished or not? Say yes or no? No one is responding. So you can take leave and we'll continue tomorrow, the next class.